lot of developers have an incorrect view on exceptions and how to handle them. In this video, we're going to look at what exceptions are, how you should handle them, and probably most importantly, where we should handle them. My name is Tim Corey, and it's my goal to make learning C# easier. If that seems like something that you would benefit from, sign up for my mailing list. The link is in the description below. The very first thing that will happen is you'll get an email from me that you can reply to. Let me know what you struggle with and what topics would best benefit you. You'll also get discounts on courses that I offer. All right, so let's build a demo application that has a problem so we can see what an exception is and what it does. Here I have Visual Studio 2017. I have the Enterprise Edition, but don't worry. The same will work in the free version of Visual Studio 2017 Community Edition. If you don't have that, go to visualstudio.com and download the Community Edition. You can also check out my video on the top 10 free tools that you can get because Visual Studio is one of those tools. All right, so go ahead and create new project. Over here on the left, we have Visual C#, Windows Classic Desktop is what I have selected. And I'm going to choose first the console application. And the reason I'm going to choose console application, this is a pretty common one for me with demos. And it seems kind of archaic, but it's really not. It's really actually powerful because a console application has very little setup work. It just kind of is. It just kind of runs. And so I don't have to get a lot of time invested in creating a demo. I would encourage you, as you learn new topics, build a console application to test those topics out. If you're not sure if you exactly know how things work, build a console app, try it out. If you're going to put a new technology into your project at work, build a console app first, make sure you know how it works, and make sure you've kind of worked out the kinks in a application you can throw away. Don't start by testing in your actual application. That's just a recipe for disaster. Okay, so we're going to call this console UI, and this is going to be our exceptions demo. The solution name. Once this gets created, the first thing we do with a console application is at the very end, add the console read line at the end. And the reason for that is because we wanted to pause before it closes the application. That way we can read what's on the screen. Now, before I go any further, what I'm going to do is actually add a class library as well. So go to Solution. We're going to add a new project, call it Class Library, and this will be our exceptions library. And the first we do is delete class 1, and then create a new class. So right click and say add class. And this is just standard setup stuff. We're going to call this our demo code. All right, so class demo code. Make it public. What I'm going to do is I'm going to create a method in here that could possibly fail. And it's a really stupid method. So don't think there's any kind of, code that you'd really implement at some point. But let's create a public int get number, and we'll pass in a position. All right, and so what we're going to have an int array. And typically I don't use arrays, I use lists instead, but this is just a little more clean this way. So we're going to create an int array, and we'll call this numbers. We're going to say equals new int, and then we'll do a open and close curly brace and say 1, 4, 7, and 2. So what we've done here is we've initialized an array called numbers. It has 4 items in it. The items are 1, 4, 7, and 2. And just remember that arrays have a zero-based counting system. So this is position 0, position 1, position 2, and position 3. So now what we'll do is we will return the number, so numbers at position. So all this method does is it has this array. We pass in a position and it gives us back that number. So if I pass in position number 2, it's going to say, okay, 0, 1, 2, it's going to pass back the value of 7. And that's pretty simple stuff. So we know that we pass a position in and we get back a value. Now, those of you who are kind of more familiar with arrays will immediately see the problem. And that is, what if I pass in position 10? Well, there isn't 10 positions here. 0 through 9, we don't have that many. We have 0, 1, 2, and 3. So position 10 would be out here somewhere, and we don't have it. So we're going to get an exception. It's going to say, hey, that's out of bounds. But I do want to add a couple of more calls to simulate what a real world feel for this would be. Typically in the real world, you wouldn't have your UI, which is the console. You wouldn't have that call the actual deep down method, and that'd be it. Usually you have a method that then would call a method, which would call a method, which would call another method. Okay, because you have, larger methods that call a whole bunch of smaller methods. So we're going to simulate that. Public int parent method. We'll have that same int position, and it's going to return get number and pass it in the position. So this parent method, when we call it, all it does, and again this is demo code, is it calls get number and returns the value that get number returns. We're going to have one more method, public int grandparent method. And you probably guess what's going to happen here. Return parent method position. Okay, so grandparent method calls parent method, which calls the get number, which does the actual work. That way we kind of simulate those layers. So over here in our program CS, we're going to add the reference. Now, this is kind of cool. I want to show you something. If I were to say demo code, I haven't added a reference in console to the exceptions library. But if I type it out correctly and then hit Control dot, one of the options, now the first 4 generate, that means create new code for this. We don't want to do that. But the last one here is add reference to exceptions library. If I do that, it added my reference right here to my library, and it added a using statement up here for the exceptions library. That's a newer feature of Visual Studio. It cuts down on the amount of steps we need to take. The only trick here is you have to type this exactly right. You can't have a lowercase c, you can't have a lowercase d, you can't have an extra uppercase. It's got to be exactly right. So demo code, and we're going to say demo equals new demo code because it is an instantiated class. So now it's called demo dot, we're going to call the grandparent. We'll pass in the position of, that's position 3, which we know will work. And I'm going to assign this int result equals demo.grandparent method. And then we'll do a console write line where I say $, couple double quotes. We'll say the value at the given position is result. And let's run this. So this should all work in theory. All right, so the value of the given position is 2. And if we look at our code, 0, 1, 2, 3. Position 3, the value is 2. Cool. Now, this demo isn't about making things work right. It's about making things fail, make them blow up. So let's do position 4, which we don't have one. Let's run this. And this is what happens. I get a system.indexOutOfRange exception. This is an exception. What it means is I had a problem and I'm crashing. So here is the exception information. We can actually go to the details here and get more information. So there's more information about the exception. But if I were to hit continue, the application stops. And the reason it stops is because we had what's called an unhandled exception. So if we were running this application without the Visual Studio debugger attached, what would have happened is it would have just crashed. Now, since we have the debugger attached, it actually paused the code and showed us the exception and showed us where it was. But if this was running in production somewhere, the user wouldn't get that. They would just get one of those nasty dialog boxes saying, hey, this application had a problem, and it's closing. So we want to solve that problem. Now, I'm going to introduce something you've probably seen before, especially if you watched any demos, and that's the idea of try-catch. Now, I'm going to first put it around where we know the exception is. That's not the place I'm going to keep it, but I want to at least show you what typically people will do when they learn about try-catch. They say, okay, I know that this is potentially a problem. If you pass the wrong position in, it blows up. So what I'll do is I will wrap the entire thing in a try-catch. So I hide the code, say snippet, surround with, I type out try, and tab. Okay, so there's a try-catch. Now, the first thing it does is it says, okay, there's an exception. And you say, well, sure, whatever. And you say, I don't want to throw it again, so I'll do this. Let me just demonstrate what happens here. First of all, it says, hey, nope, you can't do that because not all code paths return a value. Now, some people might do this. Int output equals 0. And then we're going to say output equals numbers. And then after the try catch, they'd say return output. Let's try this. Here's the code. The value of the given position is 0. Is that correct? No, it's not correct. What happened? Well, the try catch protected us from blowing up. There was no unhandled exception. And this is where a lot of rookie programmers will go, yay, I fixed the problem. You didn't fix the problem. You actually made it worse. Okay? And here's why. When you had this exception, that's important to know. Because an exception is critical information you need to know. What it's saying is, the way you expected your application to work, it didn't work that way. You need to know that because if you allow your application to continue when it's in this unexpected state, you could do odd things. You don't want odd things in your application. Think for a minute if you were an application that saved user information. And the first step is save their first and last name to the database. If that threw an exception and you just hit it behind a try and just didn't do anything in the catch, it would continue on as if it worked. And then it would save the address information for a person with no first and last name. That'd be bad data in the system just compounding itself. So exceptions are there for a reason. Don't just say they're okay or hide them. Okay? There's a reason why they stop applications. In fact, and this is something that I had a hard time getting my head around, if you don't know how to handle exception, or if you don't expect an exception and know it's okay, let the exception crash your application. It's better that it crashes your application than you continue in that bad state or unknown state. So in essence, it's sometimes better that your application crashes horribly rather than continuing. Now, I want to show you how to allow your application to continue in some circumstances. Because there are a lot of times when an exception may happen, but it's not the end of the world. Say, for example, we're saving that user and an exception happens on saving the first and last name. We could stop the process of saving their data, but not kill the application. Maybe pop a dialog box up that says, hey, I couldn't save this person. And there may be a try again button. They can try again, maybe it works. Or the try again doesn't work, they could send a note off to the IT department to fix the application, but they can still use the rest of it. So there's ways we can catch these exceptions and do something about them, but we have to be careful. Don't just eat exceptions. This is eating an exception, not doing anything about it here. Now we could say exception EX. And so what this catch is doing right now is saying, I'm going to catch every exception. And I'm going to put that exception into this EX variable. Now what we can do with this is we can actually get more information about what happened. For example, ex.message. This will tell us what happened that caused this to fail. Now let's run this and then I'll show you a better way next. So here we get this message right here. Index was outside the bounds of the array. That's our ex.message. Now notice, since we didn't do anything else, the catch finished and we still returned output. So we didn't stop the application from running. We just put out a message saying, hey, there's a problem, but we kept going. Not the best solution. So we need to rethink that. But also, there's a whole lot more information about the exception than what message gives us. So don't just give the user the message. You got to do more with this in order to help your developers or help yourself track down what the problem is. Let's put a breakpoint right here so we can see what all this EX variable has. All right, so hit the variable, and now let's look at this. And the font is small, and I'll actually capture more of this data in the actual message. But there's a whole bunch of other pieces of data in here that we can use. Let me show you. Let's stop this. Let me show you the piece of data that I find most useful. Console.write, right line, there we go, ex.StackTrace. So what this is it's where exactly the exception happened. So if we run this, it says, okay, we have an index that's outside the bounds of the array. That's our ex.message. But then down here, this is the stack trace at exceptionslibrary.democode.getNumber. Well, this is the exceptions library is the project, demo code is the class, getNumber is the method, and it's saying the getNumber is passing in the int32 position, because don't forget you can have an overload with multiple different calls to getNumber. So this is a specific getNumber method. And here's where it's located. All right, down to the democode.cs file, and that's the full path to it. Line 28. Where's line 28? Right here. So that's the offending line. So it's told us here is the CS file. Here's a full path to it, so you can get right to it if for whatever reason you had CS files all over your disk. It also told us the namespace and the class and the method, so we could get right to it as well. And the line number, so we can get right to the exact place where the problem lies. Line 128. And so that allows us to see, okay, we had an index outside the bounds of the array. That's a very specific message. It says the index, which is, we're talking about arrays, that's the the number inside here, the position. The index was outside the bounds of the array, meaning the bounds of the array are, in this case, 0 to 3. That's the spaces that are taken up in the array. We called something outside of that. Now again, it's still continuing on because we still get the message, the value of the given position is 0, because we never did anything with this exception except for log it. So let's do something about this exception. Now, this is where it gets a little tricky. What do you do at this right now here? Well, there's not a whole lot we can do because we don't know if we can continue on or if we need to shut this whole application down. And the reason we don't know is because we don't know anything about the caller. The original person, the original bit of code that called what eventually became this method. We don't know why it was called. We don't know how important it is. None of that information is down here at this level. And that's why typically we don't put try catches down here. Instead, and let's go ahead and for now, I'll go ahead and comment out this try catch. So we're back to throwing the exception. And if we start this and run it, it throws the exception unhandled. Exception unhandled, and if we continue, it crashes the application. And instead, let's go to our user interface, which is our console application. And in here, this line of code, we know this can be problematic. So we right-click on it, say snippet, surround with try. And we'll do exception EX, and we're going to comment or take this line of code out. And we'll say something like ex dot, let's do the same thing. The message and ex dot StackTrace. Now I want to show you a difference. Now, first of all, we're getting an error right here that says the value of the given position is, and the result, and that's because we declared the result inside the try, and that's these curly braces, determine the scope. And so anything declared inside these curly braces does not live outside those curly braces. Therefore, we need to move this line of code. Let's cut it out here and paste it in the try section, which is good because then we'll either have an exception or get the value. And in fact, let's make it a good value first. So let's put the value of 2 in instead. And if we run this, we get this message, the value of the given position is 7. So that's good. That means that it works when it's supposed to. If we put 4 back in, and we run this again, we get this message. Index was outside the bounds in the array. But notice there's more information here. Now, it line wraps and it's a little bit hard to read because of that. But let's look through this stack trace. And this is where this is so valuable and why we want to put our try catches as high as possible. It says the exception was at, and it gives the get number, line 28. We're used to that. But then at parent method, line 18. And at grandparent method, line 13. And finally at console UI, and there's location, line 18. What's line 18 of console UI? This line right here. That's where the exception actually happens. So why is that more valuable instead of just more clutter? Well, when we have this whole list here, we can track through where we were calling. So if you just have the get number, you don't know who called that, why they called it, where they called it, anything. With the full stack, we know, oh, it was the console application that actually called the grandparent method. It didn't call get number. It called the grandparent method. And in fact, that grandparent method didn't even call get number. It called the parent method. And so we have this full history from the root call all the way through until the actual exception. that gives us a lot of valuable information about how it was called, not just that it was called. So that's why I always encourage people, let the exceptions happen at the lower levels and let them come up through until the top level, or as high as you can go. Now, there may be a case where you say, yes, but I actually want to capture it at, say, the grandparent method level. And that's fine. Say that you have, the grandparent method is actually the overall save to the database. And it's going to call a number of methods underneath that save different parts. If there's an exception in one of them, the grandparent method should know about it so it can do some cleanup and also kill the overall operation. So that makes sense to put it there. But in general, as high as you can go, the higher the better. The other reason why it's great to have it this high level is because if you're down here at the get number, how can you tell the user what went on? Now I cheated, okay? This is a cheat right here because I knew that this class was being called from a console application, and really I even did something I probably shouldn't have done, which is call the console, the UI, from the class library. I kind of crossed all those boundaries. That's not something you should do in a normal class library because this might be called by a MVC application or a WPF application. In that case, they don't have the console. So even though technically it won't crash, what it would do is it wouldn't show the user anything. So that's not how you want it to work. You want to be able to tell the user, I had a problem. Where do you tell the user anything? The user interface. That's the whole point, is we only talk to the user in the user interface. So that's why it makes sense to put your try catches at the very top level, or at least somewhere in the user interface. But the example of the grandparent method being that overall database call, it makes sense that the grandparent method kind of process that exception and change how it responds because of that. So how do you do that? Well, let me show you. Let's pretend this grandparent method needs to act on the exception in some way. Maybe it needs to stop processing any more records. Maybe it needs to close out a connection. Okay, now normally you use a using statement. And if you watch my C# SQL video, C# application talking to SQL databases, you'll see a using statement there. But let's just pretend that we want to close out of a connection. Whoops. So what we're going to do is make a couple modifications. I'll just say int output equals 0. And we'll say output equals the parent method position, or parent method, and then we'll return output. So what we're saying is that maybe, here we're opening a database connection, and then here we're closing it. So let's just pretend like we're doing that. Open database connection. And then down here we'll close database connection. Okay? Now, without doing anything else, this is the normal application where we open a database connection, we do stuff, then we close that connection. Without changing anything else, let's run this application. Okay, so we have open database connection, we have an exception, we have no close database connection. So we now have a database connection that's kind of hanging out there. And that's not good, especially if this exception happens a lot. Say we have 100 users and 95 of them get this exception. Well, now we have 95 open connections to the database. Maybe they restart and try it again. So now we have, a bunch more, 190 open connections. Definitely not good. So this is where we would need a try catch at this level. So I can right click and say snippet, surround with try, and let's go ahead and grab, for now, I'll grab the exception EX. And the first thing I'm going to do is I'm going to show you how we can close this connection no matter what. So what I'm going to do is say finally. And what happens with a try catch finally block is finally runs no matter what. So it doesn't matter if you have an exception or not, this code's going to run. Now, what that also means is you better not put code in here that might cause an exception, because then you've got another problem. You've actually got an unhandled exception possibly. So make sure that this is good code. But with a try catch finally, this will run no matter what. The problem is that this is not the UI layer. So we can't tell the person in here that there's a problem. Now again, we're calling the console here even though this is not the UI layer. That's just for demo purposes. But here, we're saying we can't talk to the UI because this is the wrong area for that. We don't know how to talk to the UI. If it was a console, we do console write line. If it was a MVC application, maybe we open a new controller, or we have some method of bubbling up errors to the user. So how do we do this? Well, we call throw. And so what throw does is it says, okay, I'm going to catch the exception, but then I'm going to immediately pass it up the chain. So it's essentially saying I never caught it in the first place. And the reason we use this is for a couple reasons. One, I could do some kind of logging here. So I could do some logging at this line and say log that exception, but then pass it up to the user interface to actually display it to the user. Also, it allows us to have this finally block, which will allow us to do things like close our connection before we pass that exception up the chain. So with nothing else being done, we have open connection, close connection, and then we have the exception information. Because we open the connection here, we did a try and we ran this line. It blew up. So it comes down here to the catch. The catch does nothing but say throw. And so it's going to say, hey, I'm ignoring the fact that we had caught this exception. I'm going to throw it back and let the next item up the stack catch it. But before you do, run the finally code. And that finally code says, okay, close the database connection. So it has a try, it fails, goes here, it says throw it again. Okay, but first, close the connection. Then throw it up the chain where the program.cs file catches it and gives us our exception information. So that's how exceptions work, and that's how we bubble exceptions up. Wherever an exception happens, say down the get number, it looks to see if there's a try catch. If there is, the catch processes and does whatever it says. If there's not, it tells the caller who called it, hey, I have an exception. The caller looks for a try catch, says, nope, I don't have one. Pass that exception up to who called me, which in this case is the grandparent method. The grandparent method says, oh, yep, I am inside a try catch, therefore go to the catch. This catch in particular says, I'm not actually doing anything except throwing you back into the bubbled up pathway. But I am saying go ahead and run my finally code first. That gets run and it gets thrown back in to bubble up one more layer. So it says, okay, who called me? Well, that's over here. that's who called me. Is there a try catch here? Yep, there is. Therefore, I'll hit my exception block and I'll do whatever you say, and then we're done. And since this catch didn't actually say throw again, it stopped at this and said, okay, we can continue on because the application is in a working state. And that's what you have to figure out is make sure that if you don't have some kind of throw in this catch, that the application is okay to continue. If it's not, you may even want to say, close application in here, or display message and then close application, or something like that, if it's that drastic. So that's how bubbling up exceptions works. It starts at wherever the exception is, and it goes up the stack. And the stack is the parent who called me, the parent who called my parent, the parent who called my parent who called my parent. So it just keeps going up the caller list looking for a catch block. If it doesn't find one, if we have this try catch here, it's called an unhandled exception. And that blows your application up and shuts it down. Now, one of the thoughts people have is, can I have a global exception handler? And the answer is yes, but why? Because wherever an exception happens, you need to do something with it. And that's where the user interface comes into play. So you want to display it to the user, and you also need to make a decision about whether or not to continue your application. Does the global exception handler know about the calling procedure? Does it know why we called the method in the first place? Well, no. It's a global exception handler. It handles all the exceptions. So the global exception handler is not really the place that you want to have processing your exceptions. You want to process your exceptions wherever it makes logical sense. Whether it's to tell the user that something happened, or whether it's to stop and process something in order to shut down safely, or to clear data out that was half-formed, or whether it's just to say, okay, we know it's a problem, but it's not a big problem. I want to continue on. So that's why try-catch is so often done poorly, is because people don't understand what they're doing with the catch. They're just thinking, I am hiding or fixing the application from crashing. Crashing is not your problem. Your problem is you're not properly dealing with issues that arise. Okay, now let's talk through a couple of things that people get wrong when dealing with these exceptions. And let's just stay right here in the grandparent method. So I just did throw. That's it, throw. That's the proper way of putting the exception back into the bubble up process. You might see this. So we have that exception object. Let's go ahead and throw it again. So you'd think these two, just throw or throw EX, are equivalent. Let's see if that's true. It looks similar, but if you notice, we have less StackTrace information. In fact, all we have is grandparent method and then the main method. That's it. The reason why is because it says, okay, that's where the exception happened, in the grandparent method. It doesn't know about the parent method or the getNumber method. It just knows this is where it happened. And in fact, it says it's on line 24, which is this throw EX, not the actual call that caused the exception. And that's why we do not use throw EX. Because what it does is it rewrites that stack and it gives us wrong information. So don't use throw EX. Another thing people might do is say throw new exception. Might input their own message here. I blew up. All right. And they say, well, the reason I do that is I want to have this more user-friendly message to show to my end users. And if you run this, it says, hey, I blew up. It's more user-friendly, right? Yep, but grandparent method and main. That's all I got. So that also is not the solution in most cases. But there may be a case for you to create a new exception. Maybe you have an issue where your application actually generates a new exception of a different type. So let's go ahead and try doing that. So we'll say new exception. If you just type exception, one of the cool things is it filters this list by anything that has exception in the name. So you can look at the other exception types. So for example, we have the divide by zero exception, the DLL not found exception, the context marshal exception, data misaligned exception. Maybe say, well, it's really a data misaligned exception or an argument exception. So you can actually create a different exception type than the original exception. And you can say, okay, you passed in bad data. And you say, that's great. I changed the exception type and I changed the message, but we've lost all of our stack information. So what do we do? Well, there's actually an option in the throw new exception to pass in an inner exception, like EX. So what this does is it says, okay, this is the exception, and here's where it's at, line 24 is where it's created. But it was actually created because there was an exception somewhere else. And here is that exception from that other place. Let's go ahead and put our breakpoint back in program.cs and then run this code with the throw new argument exception. Okay, so if we mouse over this, it says you passed in bad data for the message, and it is an argument exception. But if we look at the inner exception, it says the index was outside the bounds of the array. That's our original message. And it gives us the full path all the way down to the original get number method. Now it's kind of small, but trust me, it's there. So it gives us our full stack for the original exception, but it also allows us to have that custom message and maybe even a different exception type. In this case, the exception type being that of argument exception. So that allows us some extra latitude in how we deal with things. We just need to look at that ex.inner exception. So if we said, ex.inner exception .message or inner exception .StackTrace, we can get all that information as well. Now the only question is, how do you kind of go through all those layers in case you're doing this, 5, 6, 7 times, which you shouldn't be probably. That just seems excessive. But what you'd have to do is look to see if inner exception is null. If it's not, grab that StackTrace and then say, okay, is that inner exception null? And keep going down the rabbit hole until you finally get to the end where the inner exception value is null. So that'd probably look like a while loop. You'd say something like, var inner equals ex.inner exception, and while inner is not equal to null, then we're going to do console write line inner.StackTrace, and then say inner equals inner.inner exception. So it's actually taking the inner exception from the inner and putting it into inner, and it just kind of loops through. If we run this, we get the stack trace in the first one, which is these two lines right here, grandparent and then main. Then we get the stack trace in the original, which is get number, then parent, then grandparent. Because don't forget it stops at grandparent because that's where we generate the new exception and pass that new exception up grandparent to main. So that kind of gives you your full stack, and it gives you a way to capture all that information and at the same time create a new exception and pass in a new, maybe more user-friendly message to the exception. So hopefully that gives you a little more idea of how this all works. And there's a lot of different moving pieces here. The big ones to kind of remember are put your try-catch at the place where you're going to do something important with it. If you decide you need to do something either simple like I just need to log it here, but I need to let it keep going, you can do this and then just hit throw, just throw. If you want to do a finally somewhere, you can do a try catch finally and then just again throw. Or if you want to get a little more complicated for some reason, you can actually throw a new exception and just pass in the inner exception as this right here, the variable you created when you captured the exception. So that's kind of exception in a nutshell. We're not done yet, but that's pretty much the philosophy around exception handling. Just make sure whatever you do, and I keep stressing this, don't just eat exceptions. That's bad. That's really, really bad. That's where all kinds of bugs come into application. That's where all kinds of vulnerabilities come into applications. And that's where bad data gets created from applications. It just don't do it, okay? All right, now I want to show you a couple of ways we can take this kind of the next level. Maybe in here we have this whole, looping through thing where we say, okay, give us the exception and all the rest, but maybe we want to handle different exceptions different ways. One of the ways we can do that is to actually have more than one catch block. So over here, we have argument exception. So we can say catch argument exception. We can still call it EX. And we have our catch block here. Now, how can I call it EX still? Well, because this variable has the boundary of living only between these two curly braces. So this variable has a boundary of only living between these two curly braces. So I can actually call the same name, and typically I do. And the reason why is because I know that EX always is my exception variable. That's a pretty standard abbreviation. Normally I don't like abbreviations for variable names. I like to have it spelled out fully because it's so easy to forget what the abbreviation is or mistake the abbreviation for something else. It goes against best practices. We want to fully write out what it is, not arg-ex. It's argument exception. Just reads so much easier. So, but in the case of exceptions, this is an exception, I guess, to the rule. So, and that's just to use EX because it's pretty standardly known that's what the exception variable is. So maybe with the argument exception, we say, you know what? I know that if you get the argument exception, that I really want to do something different. Maybe I'll just say, you gave us bad information, bad user. And that's it. I don't want to get the stack trace. I don't want to get the message. Don't want to get the inner exception and all the rest. I just want to chide the user for giving us bad information. That's it. If I run this, that's all I get. Open, close database connections. You gave us bad information, bad user. Now, why is it that it ran this catch block and not this catch block? Well, what happens with a try catch is it comes down and it finds the first catch block that matches. So it found argument exception. And it says, is the exception of type argument exception? Why, yes, it is. Therefore, run this code inside the curly braces. If not, let's come down here and we'll run this code. To show this actually works this way, let's go here. Instead of doing throw new argument exception, we're just going to do our throw. And I'll comment out the rest. Now remember, the original is not argument exception. It's actually out of bounds exception. We run this, we get our original code back, indexes outside the bounds of the array. Even though we have this catch block first, because it's not an argument exception anymore. It's a different type. You can actually have these catch blocks for all the different exception types you might think you're going to get if you want to handle them differently. Now, exception is the base type for all exceptions, which means that if none of the others catch it, it'll definitely be caught by this one, because this is the lowest common denominator. This is the one that everybody inherits from. Therefore, we know this catch block will run if nothing else catches it first. But that does mean order is important. Let's cut this code out and paste it down below. And let's again throw our new argument exception and run it. And oops, I have build errors. And it says a previous catch clause already catches all the exceptions of this or of super type exception. So it's saying is you can't even do this because I know for certain that you will never arrive at this code. Therefore, this is stupid. Don't do this. It's useless code. Even if it did compile, it would essentially be throwing this bit of code out. So you have to have it be most specific to least. The first one that gets picked up and matches is the one that gets the prize. So that's one thing to note. You can be more granular if there's a reason to do so. Don't just grab every different exception type, put a catch for it, and then do the exact same thing inside. Only pull it out if you wanted to do something different. In this case, we're saying we don't need a log every time a user gives us bad information. We'd have logs full of exceptions that are just the user did something dumb. We don't need to do that. But for everything else, we want to put it in the logs. We want to make sure that we have all the information so we can track down what the problem is. With this one, we know exactly what the problem is. It's a user problem. We can't fix users. Wish we could. All right, so that's about all we need to cover with exceptions. We've covered how to catch them, doing a try catch block. We got a little complicated with the multiple catch blocks and the finally over here, but the basic stuff is try. Everything in here is run inside the try, and so if anything causes an exception, it'll jump right out to a catch block and then run that code instead. So that's the simplistic version of it. The one thing to be careful of is I declare this result inside of the try. Therefore, I cannot use this variable outside the try. That also means if I were doing logging at this catch area right here, I cannot log the value of result in case we actually hit this value before we have the exception. Say the exception happens down here. So I'd have a value here, and I can't get to it to log to say, okay, I got back a value of 18, and then the whole world blew up. So what you need to do is if you need to capture this, you would need to declare this variable outside of the try. So just remember that curly braces mean boundaries. Anything inside those boundaries that's created is not visible outside those boundaries. That's why we can have EX more than once. So just remember that. Declare any variable you need to have in your catch outside of your try. That also means that you cannot return result. because result is declared in here. Therefore, you have to declare it outside. So just some things to think through. But that's the basics of try catch. Make sure you put your catches high enough that you get your full stack trace if possible, or at least as much as you need, and also high enough that you can actually talk to the users right where you're at. So make sure you catch it in the user interface if possible. That does mean that your library might just go ahead and throw some exceptions, and that's okay. Even Microsoft's libraries, they'll list and say, hey, I can throw these exceptions. For example, the file library might have the file not found exception. If you give me a file name and it's not on the hard drive where you say it is, that's an exception. Now, again, it's a user problem, but it's still what do. I throw an exception and say I can't do that. It's also okay for your code to actually create new exceptions. This could even be in the try somewhere. Maybe you have code like this where it says if position is less than 0, for example, throw new index out of range exception. The value must be greater than or equal to 0. That might be okay. Now, there's probably other ways to deal with it besides an exception. But if you are writing just the library and don't have access to the user interface, that might be a good solution. Throw an exception. Let it bubble up the chain. Don't have a catch here. Just let it bubble up the chain. And then let the caller deal with the exception, because that's what it really is. They gave you bad information. You can't just continue on. So it is okay sometimes to create your own exceptions if that's the right choice. Just don't just do it just to do it. Okay, don't just say, I'm always going to throw an exception unless the values are inside my range. Well, if you're in the user interface, just pop a box up that says, hey, you can't do that yet. Doesn't need to be an exception. Just needs to be an error check. So that is possible for you to do. And again, this is some complexity that we're adding to the whole try catch. Again, it comes back to try catch at the right location. Don't just eat errors. Actually make sure you handle the errors and clean up any bad data you have in your system. And if possible, alert the user to what's going on. All right. If you have any questions, please go ahead and leave them in the comments down below and let me know what still confuses you. There are some kind of advanced things we can do. For example, in ASP.NET MVC, we have the idea of the exception handler that actually displays onto the web page. We can have the user-friendly error messages that show for remote users, and we can have the full stack trace for developers if they're on the same machine as the MVC app. All that good stuff we can do. And we're not going to cover that in this video just because it's kind of outside the bounds of general exception handling. But I just want to let you know there is some more advanced stuff you could possibly do. But what I'd recommend is use this try-catch block especially at the UI layer whenever you have code that might cause a problem. Don't just wrap your entire code set in a try-catch. Probably not the right idea, because that can cause some other problems, but just wrap it around the stuff that you need, because you can also have more than one try-catch block. That way you don't have to have multiple, you don't have to declare all your variables outside the try. There's a whole lot of reasons why you don't just wrap the entire code set in a try-catch. But make sure you catch exceptions properly, make sure that you deal with them in a way that's appropriate, and make sure you let your users know there's a problem. There will be a link down in the description that has a link to my blog post on this topic that also has the source code that we did right here, just as it is. You can play around with it and try it out and see how it works for you, and just kind of saves you from retyping things. All right, so check that out in the description below. All right, I think that's it. As always, I am Tim Corey.